Hello and welcome again to my Dave for my game dev streams of the game Free Return Trajectory. Yesterday I end up hallucinating a bit with the music. And today what I want to do is to fix some problems I have. Maybe I will not do anything new, or I will, yes. I remember yesterday I told that I was that I will try to make the auto orbit. I have that already done from Unity, so I guess I just need to copy the code and see what happens. And to do that I'm going to use this planet orbital turn, no, higher orbit. So let's try to do that in this level and see what we can do. So the spaceship is in this position. I will change it to there, and I will reset the rotation. If I play, it's almost there. It's not a circular, it's a circular orbit, but it's closer this side, so it's not actually correct. What I'm going to do is to open this ship script. Let's go down to this part over here where we have this method called start auto orbit. This copy, this needs to be a boolean somewhere here. Start local for start local rotation, and we can put here export public boolean start auto orbit. By default is false. Now let's go to this bottom part. Let's uncomment this and let's try to translate, because this is the Unity version of the code. I will actually keep it as it is, copy, paste, and now let's try to interesting. Oh, heaviest object. Okay, I was thinking maybe in the Unity version I didn't have more than one object, so which one is the one that is going to be calculated orbit? It's the heaviest one. So heaviest object, this is not a game object, this will be can I do this? Rigid bar equals null. Maybe I can. So or if I can't, I just declare this up there. Float max mass equals to float minimum value. And for each object in the target, this is, where is the polar gravity? Polar gravity. Polar gravity. Oh, this is inside the polar gravity manager, so I just access the polar gravity directly. Polar gravity, copy. So for each rigid body target in targets, we get the mass of the target, target.mass, if mass is higher than max mass, okay, heaviest object equals to target. If it's not, it ignores this part, so technically this variable will be filled with the heaviest objects in the scene. So now vector displacement, heaviest object dot position minus position. We need to calculate the global position from one to the other. Oh, this needs to be a vector too. And now, next step, orbital speed. It will do some math. I don't remember how I get this, but yeah, who cares? So the mass of the heaviest object divided by the displacement. I don't like this name, displacement. Maybe this is distance. Dot magnitude, because it needs to be a float. This is length. Okay, so now we have something. Start velocity, and this is different because it is used to represent the 3D rotations. Quaternion need to be normalized to be used for rotation. It is similar to basis, which implements matrix representation of rotations and can be parameterized using both an axis angle pair or Euler angles. Basis stores rotation scale and shearing, while quaternion only stores rotation. Due to its compactness and the way it is stored in memory, certain operations are more efficient and robust against floating point errors. I'm going to copy my start. So I'm in orbital speed. So what I'm doing here is I'm rotating the thing 90 degrees. So if the planet is here and the spaceship is here, it will check this line and do pointing up. And then start velocity. Yep, this is to make sure. This is to make sure the direction is 19 degrees against the linear the linear vector between both centers. Orbital speed is that math equation. Okay, calculate the perpendicular velocity component. Perpendicular vector equals a new vector. Normalized, okay. Vector perpendicular vector equals to times orbital speed. Start velocity is not being used anywhere. It's not even being declared. Oh, the start velocity is the thing that eventually is being applied. Yeah, this needs to be something that I already have, and I can do that somewhere here where I start the okay, if I go basis X form instead of start local force, I go this gives me the rotation. This gives me the rotation, so it should be the same, but for the displacement. Paste. Displacement. Start velocity will be a float. Maybe not. Maybe a vector too. And we need to do the same thing as we did up there. Start. Apply impulse. Copy. Paste. Okay. I'm not sure if this will work. Probably not. I'm not sure if this gets the correct rotation. Let's see. Auto orbit on, and I will remove this 105. So, and the rotation, the spin rotation. So no manual setup. Let's off this. The spaceship should fall into Earth. There you go. Oh, another thing I need to check before I turn on that thing. Start orbit is not being called anywhere. Copy. So here, where we had the start apply, we do here the start orbit. Okay, let's turn on the thing and see what happens. It doesn't happen. Or maybe it doesn't happen because it's an impulse. Start orbit. Apply impulse. Let's try to do an apply force. The start velocity is not being used anywhere. This start velocity. It worked, but it was shoot out at 1 million pixels per second. Let's remove this times 1000. I will do times 0.1. Uh, 001. I don't know. I don't know what's happening. The spaceship is going out of the screen immediately. Applying pulse. Start velocity. I believe the number is too high. Let's do it again. Add more zeros. See what happens. Okay, so the problem is actually inside this. Set auto orbit. Let's print these numbers and see. Godot print and see what do I have. Orbital speed. How much is the orbital speed? Infinite. Okay, maybe this is the problem. Orbital speed is infinite. Square root of the mass of the heaviest object divided by the distance between that object, which is the planet, I guess. It's the planet. Let's make sure. So I want to print the heaviest object. And let's print this just to make sure it's not the same. Yeah, it's printing the same. It's not finding the heaviest object, that's the problem. Okay, heaviest object. Mass is the minimum. For each rigid body target in the Polar Manager targets, this start orbit happens where? This happens after we had everything. Okay. So technically the Polar Gravity Manager already have. Well, maybe not. Maybe not, because this is happening already. If this already happens first, then the planet will not be there before this. So this start orbit needs to actually happen after the ready. So it will be the first copy now. go here, and we need to if start auto orbit does that. If auto orbit only. And of course, inside auto orbit, we need to say auto orbit off. This is no longer needed here. Auto orbit equals false. Okay, that was the problem. The ship was instantiated first, so the ready function of the ship happened first, and that method that has the auto orbit was triggered inside the ready function here. And because the planet wasn't yet, it didn't yet run the ready function, the planet was not added to the list, so this was calculating only the only thing that had the list, which was the spaceship, or everything above the spaceship. So all these objects could be there, but not this. This is those situations where more than one ready would be very interesting to have by default, like ready 1, ready 2, ready 3. Anyway, so now the thing is there. Let's change the number again to something more 1. Let's see what happens if we don't multiply. It falls very quickly. So let's add 1000 as we had before. Maybe 1000 is too much. 462. This is four times stronger that we need, I guess. Anyway, let's go 100 and see what happens. Let's go 10 and see what happens. Strange. Or maybe the thing is being pushed directly into the planet. Can I reset? Yeah, the thing starts immediately against the planet, so I believe the angle is not correct. This is not correct. So we had this quaternion Euler 90 degrees times whatever. Well, this is just to rotate the thing 90 degrees. Let's Google the solution. Godot, C#. Rotate a vector 90 degrees. Vector equals to vector dot rotate blah blah blah. Okay, copy. Let's see if we can apply this way. So start velocity needs to rotate 90 degrees to the right. I guess before let's make sure. Get global transform canvas dot base, and displacement is what? Is the length of the two vectors. Let's see what we have here. Because I don't know exactly if I need to rotate 90 degrees or not. Godot F6. Failed to build project, of course. Minus 200, well, this is a vector, it's not a direction. So minus 200 is to the left. Minus 1 is a little bit up. But minus 256 is to the left. Let's see what happens if the spaceship is on the other side. Okay, now it's to the right. And here. Yeah, okay, so this vector represents the direction. Well, it doesn't represent the direction, it represents the distance. But the direction is pointing to the planet. So if we normalize this vector, we have the direction. Normalized. Okay, 0 and 1. 1 is positive in y is down, and 0 is, yeah, okay, so this is good. So this has the direction of the planet. This is the direction of the planet. We need to rotate this 90 degrees. Paste. Undo. I already lost the, come on. Already lost the copy paste. Dot rotate degrees to rad 90. Let's write it so we memorize it forever. Dot rotate degrees to rad is not like this. It needs to have math functions dot degrees to rad. Yes, 19. Vector 2 does not contain the definition for rotate. Lol. Rotated. I guess rotated is not what I want to do, but let's try 90 degrees, so it will rotate to the right. Meaning it needs to be if I don't rotate, it should be -1 0. If I rotate, it should be 0 1. No, 0 -1. Zero -1. Yes. Rotated to the right. Let's rotated to the right, but if I'm here, it should be rotated to the left because the spaceship is pointing up. But is 0 1 1 is down. Yeah, it rotated to the right. I guess I will need to analyze the rotation of the spaceship, or I don't really care. What I want here is to have a variable to set up that manually, because maybe I want to go backwards, not forward, or maybe I want to have the spaceship in a specific angle, but anyway goes on orbit. So rotate right, it will orbit to the left. Okay, so this is the direction it needs to go. Let's do a vector 2 direction of start equals to this math thing over here. Direction of start, well, technically is what I calculate the perpendicular velocity component. Yeah, this should be the same thing. Let's get gd print perpendicular vector. Technically, this is the same thing, or the purpose of these lines were to do that. So minus 0, 1. Or minus 1. 0, 1. 1 is down. 1 is down. Direction of start, copy. Direction of start, or start direction. Start direction, I already have start direction, I guess. No? Okay. The first one is wrong, the second one is right. Start direction is right, so this one will disappear. Oh, before this, let me test another thing. If the spaceship is here, 45 degrees more or less, so this should be 45 degrees to the right, which is X positive and Y negative by the same amount. Zero 0607 0607. So it should be positive. No, sorry, up is negative. So the bottom one is the correct one, and it's actually 90 degrees from this line. Very nice. I'm happy. So this one is wrong. This is actually the calculation of the perpendicular velocity component, and we calculate that. Then we rotate the thing. And the impulse will be the perpendicular, the start direction times the start velocity. Okay, something happened. Let's print the start velocity to see copy paste. Let's print this thing to see exactly which numbers are being applied, because the spaceship disappears. I don't know why. Okay, because the number is extremely big. So this should be 1, 2, 3, 4, 4 zeros. Let's multiply this by 0.001. let's do something different. Copy vector 2 start impulse equals to this. Start impulse goes here, and we can print it. $56. It was around 100 and something. So is the double of this. 2. No. Yes. This is not enough. Start local force, I'm pretty sure. Start direction. I'm pretty sure. Start local force. Okay, start local force. Yeah, let's copy this because I need to apply the force. No. I don't need to do it. This is to make the force be where the spaceship is pointing, but I don't really care. No, I know what's happening. Or maybe. If it's stationary, goes through. And here we are going to say if it's not auto orbit. If it's not an auto orbit, it will do this. If it's an auto orbit, this will not happen. And eventually it will happen. It will happen here. Okay. This number x. Oh, x minus. X minus is to the left. And y positive is down. Yes, it should be like that. It's okay. But this impulse is not impulsing anything. Oh, because impulse on the physics process needs to be a giant number. Let's go instead of impulse, add force. Apply force. Or apply central force. Now it's going to go super fast, probably. Or not. Apply central force. Maybe the problem is that multiplication. Okay. It went to where I was expecting, but this is too much. At the same time, it was quite slow. 1 is too less. Too less is not enough. 10. Come on. $100. $500. I don't understand. 1,000. Oh, sorry. 500. Save. Okay, 500 is too much. 400. And this number should be fixed because 450. A little bit more, 480. As soon as we find this number, it should stay the same forever, because this is being calculated on the mass and the distance between the planets. So any variation will depend on that. But this relation should be the same. It's a little bit too much. Just a tiny less, like 75. $65. $70. Okay. And if the spaceship starts here, what happens? So that number actually, it's not that. It's not what I was telling. Oh. I hate this. I don't know why it was working on Unity. Let's say the planet weighs 2500, and it will be divided by 100 meters. So this will be 250. Uh, 15. Okay, 15. If the planet weighs the same, but the thing is far away, so 150, the speed should be lower. The orbital speed should be lower. Maybe I don't need to do this because this is getting the rotation of the spaceship. Maybe I just use the orbital speed directly here. But if this is 150, the speed is higher, should be lower. It's far away. It needs to go slower, not faster. Very interesting. Oh, 25. Why did I get 15? Okay, this makes sense. Okay. So let's try the orbital speed instead of the other one, because the other one is being calculated according to the rotation of the spaceship. So now we are falling again. Orbital speed. 471 times 470 starting pulse. It's a lot, but it doesn't go down. Yes, a little bit to the right and a little bit down. A little bit to the right. Why? Start direction. Oh, no. Start direction is not getting the 90 degrees from the planet. No, yes it is, because we are getting the displacement, which is calculated with the planet. Okay. Normalized, dot rotated. Let's go 1000 again, because this is so strange. No, this is too much. So 90. Like I don't know, I'm tired. I'm a little bit tired. A little bit faster. Maybe I go to sleep today early. A little bit too much. Let's go like 78 or 75. Okay. Technically, we have an auto orbit. Maybe just a tiny bit faster, because this distance here is not the same. 76. And this should be this needs to be consistent independently of the spaceship position. So if the spaceship is here, it should be on a stable orbit. I don't need to set the numbers, it needs to be set automatically. Yes. And if it's here, this will end the level immediately. Where is the end level? It's here. Whoop. If I start there, I should be in orbit automatically. Just a tiny bit more, it's not the same It's not the same. 77 or 78. I don't know why that number is so weird. But if it works, it works. Now it's too much. Okay, so let's set the 77. It should be enough for this type of game. This is not a simulator, it doesn't need to be super perfect. Let's move it there. It's extremely close to the planet. And no matter the position, it always starts rotating to the left in orbit. Nice. Oh, opposite direction. Forward on this side and backwards here. Ooh, too much now. Okay, so I have an auto orbit system. It should be automatic no matter the mass of the planet and no matter the mass of the spaceship. Or maybe this is not calculating the mass. No. Yeah, who cares? It's working, is working. I just don't understand why this number is so weird. Let me try impulse and see what happens. Impulse. Because the other one is times 1000 and it's an impulse. But maybe 1000 was just a random. Yeah, impulse doesn't work with that number. So maybe I will change it later. At this point it stays like this. Okay, so this is working here. Let's do the same for, so we need to start our auto orbit. Let's do the same for the ship lander. Check the zones, check impact, start auto orbit, paste. I can delete now this Unity version. And this is the old script. I will delete everything. And we are missing one boolean. Export public boolean auto orbit. Save. Where is the moon landing? It's here. Oh, but moon landing starts over there. Anyway, let's put this ship lander over there. And let's set it up to have an auto orbit. Let's see if we fall on the moon or not. I need to take into account the weight of the spaceship, because I'm not doing that. In this case it doesn't work because this spaceship is heavier. This spaceship is heavier and technically should fall first compared to the other one. Strange. Let's make the ship even heavier, 5,000. No, it doesn't change anything. $50,000. Maybe I didn't press the enter key. What? Maybe the mass not being applied on landing. Ship lander. Where's the mass? Yeah, it's being applied. This is very strange because the behavior seems the same. Let me see how fast I can. Oh, now it's difficult to rotate. So the weight changed the way of how the controls affect the spaceship, but is not affecting the attraction between the planets. That's very interesting, but not correct. So when I play, the ship has the same route. Goes over here. Okay, now it will be easier to control because it's lighter. But I don't know why the apply force is not respecting the object mass. Maybe it doesn't, or maybe it's the central. Apply central force. Applies a directional force without affecting rotation. A force is time dependent and meant to be applied to every physics server. It's equivalent to use the rigid but applies force. Apply force. Let me look at polar gravity manager. We get the direction. We calculate the distance. If the distance is higher than 0, we point to it. We are multiplying the body mass with the target mass. So we are using the technically we are using the body's mass. Yes. Well, I don't know. I'm tired. I cannot think. So I guess I will solve this in another day. Probably not tomorrow or Monday or something, because I'm no longer in a stable orbit. These parentheses here were actually doing something. Godot says parentheses can be removed, but they can't. I'm sorry, Godot, you are wrong. Because the math do not work without those parentheses. Yep, I didn't fall. But I'm falling. I'm lower now. Why? What's wrong here? It was because I moved the thing. Let's return to the the manual speed. We entered the scene from here. We are almost in a stable orbit. We just need to go forward, more or less here. Oh, this is not working correctly again. This is so strange. Let's do the other level. Let's play the other level. Higher orbit. Something's wrong in that lander. This one is stable. This one is very stable, so the problem yeah, this lander has something wrong here. Oh, I'm not applying the auto orbit, come on. I'm not applying the auto orbit. That's why I need to sleep. Where is the copy? Ship lander. Oh yes, I am. Maybe not. Yeah. Okay. Let's try again. It's very difficult. Anyway, let's do the auto orbit and see what happens. Not the moon. In the spaceship. Auto orbit on. Auto orbit on. If it's on, If it's not out of orbit, it will. Okay, where is the physics process? Why does it fall? It shouldn't fall. Or maybe it's the weight. No, but it's not moving. If auto orbit, start auto orbit falls, reset what it is, gets the thing from the polar gravity. Print starting pulse. I'm printing something that I don't know where it comes from. Is this? This should happen only one frame. Okay, it's not this. Come on. Find all prints. Get the print. Replace by GD print. Both numbers are positive, so to the right, to bottom, and to the right. Very big numbers, but they are not being applied because this doesn't go anywhere. So this is actually being printed. So this is happening, but somehow this apply force, it's not applying anything. Freeze, no. I'm sorry, I'm too tired, I cannot think, so I will end the stream and I will solve this in another day. Sorry about the boring stream, and see you in the future.